This conference will now be recorded.
All right. I don't know whether that's going to be useful, but we'll try that. All right, guys. So just as a way of introduction, I'm Forrest Pardue, and I've been around the reliability arena for a long time. Back in the 70s, I worked with Babcock and Wilcox doing startups and nuclear power plants when the instrumentation for reliability took a semi-trailer. In the 80s, helped a company called CSI Computational Systems build the first really walk around predictive maintenance or vibration analysis tools. And by the end of the 90s, Emerson bought that company, and I started this company, which is 24/7 Systems. And our thoughts were that the technologies behind predictive maintenance and reliability in general, the hardware technologies were all pretty strong, but the use of the information in plants just wasn't very strong. The plants they were doing a lot of inspections and still had machines failing in service. And so we set out by the early 2000s, set out to build a set of tools to use the predictive information better in plants. And so that's kind of where we're coming from. I'm just going to talk about our experience in some of that and some of our clients, and we'll go with that here for a little while. So a single database for reliability technology. And if I can get the buttons to work here, which I'm not, there we go. I was having problems with getting it to advance. So anyway, let's look at a slide that either this is incredibly slow or I don't know what I'm doing. Why can't I get it to advance here? All right, we'll take a alternate approach of not getting to the slides to advance. Oops. Sorry, it'll be a moment and I should have this hopefully ironed out. I'll just work from here for right now. Terry O'Hanlon, Reliability Web, did a survey. He had 376 respondents, and he asked essentially what was the problem in implementing their reliability systems and reliability program in the plant. And so I guess the program was low sustainability rate. So why they aren't able to sustain their reliability program. And so the answer he's got back was 8% was not enough manpower. 10% was the translation between the reliability information and the CMMS. I haven't read Terry's article close enough to know exactly what that means, but what I think that means is that there's just not the capabilities in the CMMS to handle and track reliability information very well. But then you get to the really big ones, the lack of executive sponsorship. That means your management isn't really supporting, or when management needs to cut back and save money, the reliability program is one of the first things they look at. And so 35% of the respondents say that was the biggest sustainability problem. And then even bigger than that is cultural resistance to the reliability program. And we're going to talk some about that, but just in general, from my experience, when a reliability program is working, it's ingrained in the culture of the plant. They don't know how to do it any other way. If reliability is kind of a sideshow to maintenance, then it's probably something that can be dropped out quickly. In plants where reliability is ingrained, they can't remove it because it's such a part of the culture of the plant that it's just how they do things. So we'll talk more about that. But anyway, that's kind of an independent assessment of why CMMS or not CMMS reliability programs tend to fall apart or not be sustainable. One of our clients is North American Stainless, a large facility. They bring in, you can't see it on this picture, but they bring in barges of scrap stainless and then process it out to all sorts of stainless sheet and products and bars and so forth. So they have, foundries and castings and rolling and hot rolling, cold rolling, and so forth. And so a large facility, and so let's talk there. They've been using Tango Tango is our product, by the way, for this, but they've been using a single database for at least 10, maybe 12 years. So some of the things that they say about this, and so the next 2 or 3 slides are just things that they say about the program. It provides a platform for collaboration between plant mechanical maintenance and predictive maintenance. So what they have is a central predictive maintenance group, and they have each operating area has a area supervisor and reliability engineers. And what they found is that early on is that the predictive maintenance program, while a lot was going into it, the individual areas weren't doing a very good job of following up on the information and actually making the plant more reliable. So we'll talk about some of what they did there in a few minutes. Main advantage of a centralized database is you can pull the current status and full history of a piece of equipment at a glance. Again, what they're saying is that they really like the ability to go to any one asset in the functional location structure. So you've got a functional location structure that's pretty much the same as your CMMS. And so if I go to any one of those locations, assets or components, I can bring up my full history of failures, of inspections, of root cause problems if I've got that. So everything there is in one place, and they're saying they like that. All right, let's keep going here. By the way, this is heading. The heading here is Andy Robinette, and so Andy is the head of their predictive group, and I did this as a presentation for SMRP a few months ago, and Andy and another guy that's coming up, Kevin McGee, were a part of that presentation. One thing that North American Stainless is it's such a large plant. They use a combination of inspection groups. They've got they've got a plant team that does vibration and thermography and oil analysis for the different plant groups. But then they've also got, for some of the areas, they bring in contractors. And so they've got vibration and infrared contractors coming in. And so one of the things that they've done is make it so that those vibration and infrared contractors can go directly into their single database and put the information in, as well as their plant teams. So everybody who is generating reliability information, at least from the standpoint of predictive inspections, are putting the information, the results information, into a single database. But even more than that, in the single database, since everybody's putting information in, you can see which pieces of equipment have been measured, which ones have been missed, and which ones have problems. And so it's a lot easier to get a handle on what I'd call asset health from a single database than if I have a report for each individual inspection technology, or more commonly, a report for each individual inspection group. So I may have 4 or 5 contractors doing work. I may have 4 or 5 different reports coming in from those contractors. So So now he's saying that the engineers document everything in a shared database, reports are centralized, feedback is exchanged. So I think Andy is just saying here that with that central database that they've got everything coming into it and everything coming back out of it for the people in the plant, all out of that one database. All right, more about North American Stainless. I think the next one jumps off to another plant. Again, what Andy and North American Stainless is saying is they went into or started working with root cause failure analysis after they got control of their predictive inspections and got control of those technologies pretty well. They decided that root cause failure analysis was important to them. And so when they got started, one of the things they found is that there wasn't much standardization across that process either. The different areas supervisors were doing it in different ways and putting the information in different spreadsheets. And so again, pulling it together was difficult. So again, the central database brought all the information together into one place where everybody now documents their information in the same way, and the knowledge is shared. And again, sharing of knowledge is essential. I've seen programs back in the earlier days of starting this where an oil problem may be identified on a machine, a lubrication problem, contamination of lubricant, and that went off to an oil specialist in the area to fix the problem or to write the work order. And a vibration problem on the same machine was called, and that went off to a different person to fix the problem. Wasn't too long before, in that particular case, before the machine failed again because the bearing failed. It failed because they fixed the bearing, replaced it because of vibration, and not fixed the oil contamination problem. And so they just repeated the problem because communication was poor. And so again, anytime you can see all of the faults on a different piece of equipment from all of the technologies and inspections, it's certainly an advantage to you. Kevin McGehee is a different person who was in our presentation. And Kevin, just as it says, over the span of a couple careers, a couple of employments, he's implemented a single database in about 15 manufacturing sites. And so let's see where to go with that. So anyway, he's walked into these companies and helped them set up the central database concept for each one of the plants. He's found that the senior level management status information for the entire corporation with multiple sites. Again, I'm going to get to some of the information he's produced here in a little bit, but what he's found is that the senior management for the corporation wants a roll-up of what's going on in all the plants, and they want that standardized. You've got to have the information the same across all the plants in order for you to roll it up across all the plants. So again, getting one common source of the truth for each plant, having your asset health information where it now can be rolled up so that I've got an asset health indication or reading or metrics, I guess is the right word to say, for the whole plant's important. Let's keep going here. A common problem is keeping all the information from different production unit sites apples to apples. I think that's what I said just a moment ago. You've got if you have multiple sites, and I was talking to one of the guys that's here on the presentation a moment ago, and he's got multiple sites across the country. That's common. For example, we work with all the Anheuser-Busch facilities. I think there's 30 facilities. And Anheuser-Busch takes the approach that they'll let the plants do any contractor or in-house teams for inspections they want, but they want it all rolled up in a common way to corporate, so the corporate can make sure that the work's being done and that results or that pieces of equipment are being repaired based on what's being found. And they made the comment one time that they were spending a lot of money on inspections, and they just weren't sure that they were getting the results for that. They wanted to make sure that they were getting the results. And I think that's a common, when you've got multiple plants reporting to a corporate management that wants to watch out for reliability. I think that's pretty much a common theme. If you want that kind of metric and KPI information, I mean, one way to do it is to hire somebody that pulls it together. I have certainly talked to corporations where they spend hours and hours pulling together information across the plants and putting it into presentations and KPIs and so forth. And really, plants don't want to do that. They don't want to spend the money for that. And so having a database where the information is going in, and you can press a button essentially to get the information out, is critical. And so that's one of the things that the central database gives you, is the ability to pull that information out into KPIs in an automated fashion. Single source of the truth, I think we mentioned that before, but you've got all the different plants, and they're all doing things the same way. They're all reporting the same way. All the information, the KPIs are going up to management the same way, and that's just absolutely critical. Directors and managers can see the detailed aggregated information for the entire corporation down to each production unit. And so I mentioned Anheuser-Busch a moment ago, and just to throw that out a little bit, the VP level, the director level at Anheuser-Busch wants to know, and all they want to know for reliability is how many critical problems there are that are greater than 15 days old, and how many moderate problems are greater than 45 days old. They figure that if they're at the VP level, they figure that if there aren't any problems that are outstanding, that are old and not getting addressed, everything's good. Everything's working like it's supposed to. And they only want to get involved in where they seem to be a problem getting it resolved. And so then they can, they or somebody can now drill into that problem and find out, where it is and what it is and why it is. And so that's part of the reliability of the single database. Most of the time in existing programs, if they don't have a central database, and a lot of plants don't, what they've got is standalone, minimally connected databases. So you've got databases for vibration, or even not databases, spreadsheets coming in from the different inspections, and all the inspection schedules and the results and so forth are kept on spreadsheets. Analysts spend countless hours locating data distributed across the islands of information, integrating the information to the useful and actionable information is a problem. We've said that 2 or 3 different ways in the previous slides, that just the act of pulling reliability information together in a plant or corporation is painful if you don't have some sort of central way of capturing it. And so the illustration is just illustrating the reliabilities of information, the islands of information with the CMMS: motor testing, vibration analysis, infrared analysis, oil analysis, repair data, root causes. I mean, there's lots of different pieces and parts to reliability information. And if you have a problem, a critical problem on a machine, you're going to have to go digging for it. And the last thing you want to do is be looking through multiple spreadsheets, multiple reports, multiple databases to try to pull that information together. So really, your central database must allow all sources of information to put the information into the database, and then it must allow all the users that need that information to pull it out of the database. And so we'll talk a little more about that, but The big thing is that there's lots of pieces and parts to reliability, and the big thing is having everything you need all in one place. Just as an example, some of the information you're going to want to collect from into a single system: identification and design data, design documents, purchases, stores and stores testing, installation and location details, condition testing results, contractor management, failure analysis, warranty information, and then collective analysis of all that, of how your repair vendor is doing, what are your main types of failure, what types of equipment are failing the most, what areas are failing for what types of problems. Lots of things you want to pull out of a reliability system. Again, the current state of most systems, there's not any standardization. So what one contractor does may be different than another contractor. Even what one plant team for one set of technology may be producing things that aren't standard with another plant team doing a different technology. So are your failure severity scales the same? Are your locations the same between equipment names? It's really often when I look at a program and see the CMMS name is one thing, the vibration names for the same machine are slightly different, the names for the buckets or the infrared may be different. And so getting all those just equipment names standardized and non-legacy and things like that's critical. So standardization, you cannot integrate information if you don't standardize it. So the first thing you got to do is standardize it. Then you begin to integration. Right now, there's not much integration in plants, but again, just moving up from that a little bit to integrate information, vibration integrated with oil, integrated with infrared, integrated with ultrasound, so forth. It's just hard to do if there's not standardization. Again, if you haven't standardized and integrated, it's really hard to communicate that information because it really comes out in bits and pieces that aren't compatible with each other. Accountability is a big thing. So you communicate, you put out that information. You've got to make people accountable for getting the repairs done. So we talk about asset health and bridging asset health with work management. Somewhere in between asset health and work management, you've got to add an accountability step. And I'll talk about that a little bit, but we call that the red meeting approach. This presentation really isn't going to talk about red meetings, but I will mention it a little bit. And then no ability to analyze performance. And so I started off talking about these as things that are kind of current states of plants that don't have a central program, but then I kind of blended it together for how you're going to have to put a program together. And I guess this program does the same way. You got to standardize, then you got to integrate. Then once you've integrated, you've got to do a good job of communicating that information. Once you communicate it, you got to make sure accountability happens and that people really are accountable for making the results happen. You've got metrics of the program to how well things are. Number one, how well things are being generated. Did I measure the things I said I was going to measure at a time I said I was going to inspect it? And did I repair it like I thought I would repair it, and it didn't fail in service? There's lots of reliability engineering tools. What are my bad actors? And so if I have a piece of equipment that fails every year, then it's probably appropriate that I look into that piece of equipment and figure out what its root cause of failure is and do some reliability engineering to make that piece of equipment last 10 years rather than 1 year. And then management tools. How do we show management that this program is valuable? And again, so we've got, this is kind of the scenario for one database, the things that I really have to accomplish out of that one database. Those, tools that are used at a lot of plants that right now the CMMS system, a number of plants will start off trying to use the CMMS system. They'll try that for a while and find that it really doesn't accomplish what they want to do for managing the reliability program and reliability information. For us that produce a reliability information management system, what we find is that most of our clients have SAP or Maximo or JD Edwards, one of the big CMMS systems, and they found that they really can't accomplish the management and communications with the reliability of the reliability information through a CMMS, and so they moved to other things. So typically they'll move to spreadsheets, and so now you've got spreadsheet. I'll call it Excel hell. You've got spreadsheets for your vibration program. You've got spreadsheets of what machines need to be inspected on what intervals, and essentially the inspection task. You've got spreadsheets of the results and what's got a problem and when it's going to be fixed and what the work orders are. You get the idea. You've got lots of things going on with spreadsheets. Somebody put Microsoft Access in there. I'm not really familiar with that. And then the last thing here is we've got a commercial reliability information management system. Again, that's what we produce, but I'm trying to stay a little bit generic here in the fact that you need some way, probably a commercial. You don't want to have to build that single database yourself. Again, I've seen people try that, and it's painful to maintain a system that only is used by one or a few plants when you can commercially get that. Excuse me, let me get a drink of water here for a second. When you can commercially buy that, and you've got hundreds of plants maintaining that program. Oh, let's see where we are here. We're going to talk, CMSs. There's a lot of reasons why CMMSs aren't good at doing reliability information, and so they aren't built for it. Typically, IT owns the CMMS system. You got a lot of perishable. Reliability produces perishable information. That means if it's not acted on fairly quickly, machines fail. And so CMMSs may have thousands of pieces of work order information. How do you make sure that the 200 or 300 that are perishable get acted on quickly and somebody is accountable for it? So again, perishable information, not visually oriented, difficult to manage, finds earlier. So a CMMS manages problems once you're ready for a work order. How do you manage all the things that are not quite ready for a work order, but you certainly want to keep an eye on them? Making sure that work orders are written and executed before it fails. And even with a CMMS system, usually a number of spreadsheets are needed to supplement the CMMS system. So again, this is just things that people throw out as to why the CMMS system wasn't useful to them for managing their reliability program. This graphic just showing that the CMMS has lots of things that it's responsible for with manufacturing, sales, finance, human resources, procurement. But when you get into maintenance, you've got a lot of pieces of maintenance, but when you get down to reliability, it's usually just a really small slice of what a CMMS does. And so, a purpose-built system that's just for managing reliability information tends to be a better fit for most plants. I'm going to jump through some of this because we've talked about it, but the spreadsheets are another way that people try to manage this. Excel hell, it's not uncommon to see a dozen spreadsheets or even 24 spreadsheets of reliability information that all have to be pulled together. It's interesting sometimes. And then, what happens with spreadsheets is as soon as the originator of that spreadsheet concept leaves or changes, then somebody else has to pick it up that can't quite manage it the same way, and things fall apart. So spreadsheets just are not a successful way to manage a reliability program. All right, so let's talk about the single database concept. Goal is one database which contains all the asset reliability information. It can be accessed by anyone in the plant, inspection contractors. You want to integrate in with the inspection, repairs, and root causes. So if you have an inspection find that says this machine is failing bearings, as an example, then that machine is going to be sent out for repair. Well, what happens at the repair shop? They open it up, they can see the root causes, they do a repair, they can tell you about not only the repair but the failure and so forth. Capturing that information is wonderful. If you don't send it to a repair shop, if you scrap it, just doing an autopsy and putting the autopsy information in is important. And then you got root cause information. So why did it fail? Why is this class of machinery failing? What can I do to make it live longer? All of those things need to be in the program. And you're going to bridge the gap between data systems and work management. So you've got all of this stuff leading up to all your asset health information. Now, how do I get asset health over to the work order system and make sure the work order is executed? Well, let's see. I'm having all sorts of problems here today. This slide is talking about several things I think that are important. Having the central database, but using the same asset location and functional location information that's in your CMMS is critical. Whenever we set up a database, the first thing we do is grab the functional location information from the CMMS, and that becomes the same functional location structure for the assets in the reliability system. Because you have to talk back and forth. At some point, you may even want to automate the process of moving back and forth between the two systems. And so you have to have the functional location numbers and IDs and so forth the same between the systems, if at all possible. And also, it's not uncommon for people to move from SAP to Maximo to this or that. And so it's important that as you make those moves that you migrate your other systems with that as well. Let's see. Again, providing company-wide, area-wide metrics. Let's keep going. Sources of information, lots of sources of information coming into a central database. And so you've got to find a way for everybody that's producing that information to get into the system. What we've done in some ways is create specific portals for information. So, for example, there may be a way for your inspection teams to put information in that's very different from the way that a repair shop puts information in, or an oil lab puts information in. And so that's a good thing, is that you can have a very customized portal for a set of users. It all goes into the same database, but you can tailor it for what you want that customer to be able to put in, and also for what you want to limit them in seeing in the system. I'm going to skip over this. I think I'm looking to see if there's anything here that, and this is just talking some of the justification behind a central database. Obstacles for why you can't get into or why you can't use some of these other systems. Again, skipping through this a little bit here. Let's move on here. I'm skipping this, but we've said it all. Everything we've said here that's in this slide. We've talked about difficulty in knowing the condition of equipment and poor accountability and so forth. So make the results easy for the analyst. Don't create extra work. Force the use of standardized location names. Also force the description of findings and recommendations. So this slide is just saying everything you can standardize or put into a pull down, make the system that way. You don't want free text if you can help it. Again, I end up generating or integrating data from old systems sometimes. It's not uncommon to find the term for General Electric put in 5 different ways: General Electric, GE, G period, E period, and that's just a nightmare to start trying to mine and utilize that information when it's inconsistent. So you've got to really, pull in faults. Don't let them write out fault. Don't let the users write out faults. You can give them a place to write out a description to expand that, but you want the faults, the recommendations, and so forth to come from standardized list if at all possible. It's just saying let the formatting of the reports happen dynamically behind the scenes, and so you're dumping a lot of information into a database. Now people want the information out, and so being able to produce a report. There's all sorts of reports that people want. We get requests for specialized reports all the time, and they want it generated in a certain way, or they don't want a report. They want an Excel spreadsheet that's got 50,000 rows in it because they want every assessment that's done on every piece of equipment for the entire plant over time or whatever. So and that's easy to pull out of a system like this. That's just, when people start needing that sort of information for going into a lot of times they're going into other KPI systems too. So again, it's not uncommon that your systems, like the reliability system, now want to feed a global KPI system or dashboard system that the plant's using. Again, we see that, and it's not uncommon at all. It's talking about standardization, but we've already talked a lot about standardization, so I'm going to skip through that as well. Integration. So it looks like I'm just reiterating things a lot of times here, so I'm going to keep moving through this. This is just talking about, there's lots of people putting information in, contractors, vendors, plant sources, PDM teams, repair shops, and so forth. You've got your single database, and then you've got everybody pulling it out. Operations, maintenance people, reliability people, so forth. All right, so we get into here's a plant, a typical plant. And so they've got lots of inspection technologies going on. I don't know whether you can read this. Let's see if I can blow that up any. Well, try that. Yeah, there we go. Not quite what I wanted, but if you take a look at this, you've got the oil lab has got only 19 assets. Vibration inspection, 100 assets. This one's not a very big plant. Here's lubrication's got 952 assets. Ultrasound's got 1,000. Infrared's got 1,400. Okay, here's vibration at 500. These are components. In our terminology, a component is like a pump or a motor that makes up the asset or the asset train. But anyway, you get the idea that you've got a lot of different inspections coming in. You can now roll up an asset health to say, for example, that in vibration, 8% have problems. Another 2% have minor problems. That gives you 89% that are good. So now, there's lots of ways we could go with this information. 8% is not a great number for that. I like to see that number more like 2 or 3%. And so, let's start looking to why and what it's going to take to move 8% of our assets from having a problem to being normal. You see that infrared is looking a little better with only 2.5% abnormal. This is another KPI set where, in this particular case, they've taken that same information for plant. This is plant A, B, C, D. How many are red? How many inspection points did they cover during the interval? This may be a month or it may be a quarter. I don't remember this, but so they've covered 6 on the plant B. They've covered 6,000 inspection points. The mean time between repair, that is how from the time it is found to the time it's fixed, how long it's taking. They want that. They've got a target of less than 60 days. This is 131 days. This is 58 days. So I'd have to look at each one of these individual plants. But what you're seeing is that whatever this mean time between repair or mean time to repair is great. This one's not bad. This one's not bad. These two plants, somebody needs to start looking at why they can't get the repairs done in a timely fashion. Percent coverage. This is how many machines that are being covered out of the total number of machines. Percent condition entries. This is how year-to-date condition entries. So this is how many condition problems they've had. And again, you see that this particular plant's had 847 condition problems, 350 condition problems. How many findings are open right now? How many problems are outstanding? Again, I've got one plant right here with a lot of findings that are out and open. Open findings not checked off, and then cost avoidance. We haven't talked about cost avoidance. I will and probably will do, or have and probably will do another whole one of these Tango talks on cost avoidance. But one of the things that a plant should be doing is documenting for their failures, for their problems, what it did cost to repair, given the fact that the problem was found and repaired before it failed in service, versus what it would have cost if it had failed catastrophically or failed in service. And so that's what this column is giving. This set of plants is doing that calculation and producing numbers on cost savings. Some of these other things are just the different technologies and what they're saving by technology. This is percent coverage, PDM coverage by technology. So what technologies are covering how much? Again, I'm not familiar. A lot of this gets customized by the plant and by what the management wants to see from the program. And so this is just an example of a monthly scorecard that's being produced for a particular corporation. So we're back to this whole slide again. 48% cultural resistance is why programs aren't successful. Well, again, what I see and what you can now see from the standard database discussion is that a lot of this stuff is things that you put into the plant that are standard operating procedure. All the condition inspections are done this way, and they're not done any other way. And this is the information that's handed out. All of the people writing work orders are doing it this way. The work order information is coming into these dashboards. We're going through a red meeting, which I didn't talk about, but again, we'll do another Tango talk on red meetings another time. But all of that information is coming in to be being analyzed and digested every week or every couple weeks, and we're making sure that problems have an owner and somebody's doing something about it before it fails in service. And so all of that becomes just part of the culture of the plant, and that goes a long way to resolving this number one big issue. And again, I see that in real life. I'll get calls from plants that say, what are we doing wrong? I'm putting out all this information and nobody's looking at it. And if that's the case, you haven't made it to where they can operate without it, and you want to make it where they can't operate without it. All right, the next one is lack of executive sponsorship. I mean, big thing is that the executives don't understand reliability. They don't value reliability. They don't know what it's, they don't know that the payback is, and so you've just got to do that cost analysis calculation for them. You've got to present to them what this program is saving, and I know it's something that has to be kind of picked out of the air sometimes with some of these numbers, but it's better than nothing. And so I've really found that that cost avoided cost calculations are critical. And then the other two we talked about, those are resource things. So those top two are things that that we want to address with our single database, and I think we have. And I think we're pretty much wound this up. Oh no, this is just talking about those four things. I think I've talked about all of this already, so no sense going through each one of those bullet points. Questions? Anybody want to throw out some things to talk about?
Well, thanks for presenting the concept. I do see the benefit in it. I was kind of interested in the application. Looks like each person who enters the data, they're entering into a format, or is there a bulk upload to get that up?
No. Well, all right. So let's. I think that's a great question. What we decided in building our system is that we're not a data system. We're a system that integrates actionable information. And so you've got a vibration system and an infrared system and so forth, and they all have data in them. And so there's some people that think that I want to pull all those wiggly lines together and look at them all on the same screen, and somebody will make a good decision out of that. I don't know whether that's true or not. I haven't seen it be something that has been successful, but for us, what we want is for each of the technology, all the analysts, to now give us what is the severity, what's the fault, what are the recommendations, and give me, if I'm going to do anything with data, give me a picture of the data. Give me that trend line as an image. Give me the infrared and visual images so that I can see where the hotspot is. But I'm not really looking for capturing the data in the single database, in at least the way we do it. And so I could show you. I'd be glad to show you what that looks like for an analyst. But it's just a simple little screen where the key information, the actionable information, is captured and then integrated, and then all that's rolled together into a dashboard. While we're talking, I'll go to a real database for a moment, and well, I hope I will anyway. By the way, if you haven't been there, this is ts7.com. So that's our homepage. There is some great articles. Let's go to where am I at? Library. So under articles and papers, there's 20 years of articles and papers and presentations at conferences and things. Good stuff there. One of our clients, Municipal Sewer District of Cincinnati, has said that we can use their database for demos, and so it's a real database, and everything. If I pull something up, it's going to be something going on right now. So again, here's some quick metrics. One of the things that we decided, we had tons of reports. And you can dig through and find reports that, lots of reports. And so one of the things that we decided to try to do is bring some of the key things out of some of the reports up to the front and call them quick metrics. And that's what's showing up here. I'm going to go to an integrated condition status report. That is going to be the open problems. So right this second, there is at the Mill Creek site, there is a motor on a settling tank 1E North Bay pump, 3E pump. Vibrations causing a problem. It's been open for 53 days. It's got one work order. These guys have a interface to Maximo, and so they can click a button. It writes this information over to Maximo to create a work order. Maximo hands them back a work order number. This is the in their case, this is the crew that's assigned the work. And Doug Little is the analyst that put it in, and I think that's about all that's there. Yeah. So anyway, you get the idea. And so if we then go into the details, they want to replace the motor. Vibrations quickly developed relating to the looseness in the bearing housing and will cause catastrophic failure if not repaired. Again, there's the work order number. They could have put in some linked documents to show that. They didn't for whatever reason. When the work order is completed, in their case, because they have the automated link, they'll get a check off. And that'll show back up on the dashboard that the work order has been completed. Then there's one more step in the reliability process where we want them to go validate the repair. So Doug Little or whoever has responsibility now needs to see that work's been completed, and he needs to make a special trip out to that machine to make sure that the alignment's good and it's been put back together well, and he validates that repair. Then it comes off this list.
Are you able to generate a work request for Doug Little to verify? Or how's he know to go do it?
The way he knows to do it is this day's awaiting checkoff will come up and say checked off or T code, or there'll be some word that means the work order has been closed, and so that's the way he knows it. I hadn't thought about generating a work order. No, we typically do the work order. It's customized for each plant, and so they tell us what they want, and that's never been a request, but I think that's a good idea. So anyway, we'll get the notification from Maximo that the work order has been completed. The word checked off will appear here. I don't know that they've got any that are checked off. Let's look and see. All right, days awaiting check off. Yeah, everything, they've checked off everything that's hanging out right now. And so they've got some as new as 7 days old, and I saw one that's almost a year old there. And more than likely, when you get things that are a year old, there's a capto problem or something that's keeping them from getting repaired. I'll give you just, I don't know, by all means, I don't want to take your time up if you need to drop off, but I'll show you something else that's kind of interesting for a moment. Let's run so that you see they've got cost tracking and things like that. Where is the risk report? I'm using this report to tell me where the bad actors are. All right. So in the way we do things, every time you measure a component and assess it as having a problem, you do an entry. But those entries may have they're grouped together into cases. And so if I have a bearing problem that goes from, from 3 months ago till now, I might have 3 or 4 entries in the case before it's repaired. Well, so this is telling me that on this particular, what have I got here? A drive, I've had 10 entries. On this motor, I've had 9 entries. Let's look at that for a minute. I don't know what I'm going to find because I just picked something out of the blue. But you see, they've had, all right, so they had 2013, they had a problem. And so where am I at here? Case number. Each one of these case numbers. So 2013, they had a problem. They had another problem. 2014, they had problems. Then they looked like they went 15, 16, 17 without a problem on this particular machine. Now they've got a problem again in 18, nothing in, well, a little bit in the early 19. Then in 2020, and nothing in 20. Anyway, you get the idea. This is obviously a bad actor. It's failing a lot. So now what's going on with that? Vibration, lubrication, lots of lubrication. I could dig into and replace inboard bearing. It's a vibration problem. Bearing vibrations jumped up on this motor. Anyway, you get the idea that there's not data here. We're taking in what the analyst knows about it, and we're able then to pull that out and show you what's going on with it. So look at more of this. Filter in the circulation fan located at the top of the DC motor. Power cooling is restricted by a dirty filter. But you get the idea. Anything else you'd like to see or talk about? We haven't talked about root causes. We haven't talked about repairs, but this gives you the idea that you're getting everything into one database. Neil, anything?
I definitely great information, and it sounded like you were talking about our company with some of the challenges. So I definitely like to follow up and talk more. And we did talk in the past, but what happened is the project got delayed, and we're kind of repackaging. So I'd definitely like to reach out to you and talk a bit more.
All right. Well, I don't know whether you went on the demos of Tango, but anytime anybody wants to, I'll be glad to, do one of these, demo the system, show it to them, and kind of talk through all this again. Just kind of tell me what you're interested in, and we'll do that.
Okay, great, thanks. I do have to drop off now,
all right.
But really right to the point, great stuff.
All right, great, good to hear. And Al, I see you're on here. I'm good to see you as well. Al, you there? All right, I'm going to close things up here. Oh, there's Al.
Now it's muted.
Hey, buddy, what you doing?
Oh, just
what you doing these days?
Working from home mostly. Trying to.
Who you are you working for?
Well, I got my own little thing going on. I'm contracting to different people. Hendricks Precision one.
Well, yeah. Bill Sly works with Hendricks as well, so I hear about them some.
Okay. Yeah, Bill. Okay.
Yeah, sure do. Bill and I do a lot together.
Well, that's good. That's good.
But good to see you. You concentrating in oil, or what are you concentrating in these days?
Well, I'm mainly doing some training, alignment training, bolting training, that kind of stuff, and consulting every now and then too.
Well, I have I've called and talked to several people. Bill is one of them about technical papers to do this year. And I didn't think to talk to you, but if you got any ideas that where you'd like to work with us on a technical paper on some subject, let me know and we'll get into that.
Okay, well, I'll give it some thought here. When you say technical paper, you're talking about using a Tango, right? More or less.
Well, not maybe some. Bill and I are going to work on one for walk down. Talk about how to do and what you need from a plant walk down.
Okay. Yeah, I had one all put together last year. I was going to present it to SMRP, but then with the pandemic and everything, we ended up getting canceled. But I was going to do it on. Actually, we're going to do a workshop on bolting. That's a big thing.
Oh, really? That sounds great.
I got it all put together.
You go into much on you go into much on the vibration signature across loose and broken and that sort of thing?
Not too much on vibration, more along the lines of getting the proper torque to begin with, and the different tools that you can use to get that torque, and measuring the elongation of a bolt to tell you what kind of torque you do have, because torque is not really a exact science, as you know. So I talk a lot about elongation of the bolt to determine the force. So yeah, I do. That's the kind of stuff that I concentrate on.
You're probably familiar with this, but back in the nuclear days, instead of torque wrenches and things to tighten reactor head bolts, they have this hydraulic piece of equipment that screws down to the bolt, stretches it, then you tighten the nut and let it back down.
Yes, that's actually the way to do it. That's bolt tensioning. Yeah, that way you
yep.
Speed. I mean, it's.
I always got a kick out of that.
Oh yeah, and then of course another good way to do it is turn the nut. When you turn it nut a certain degree, you're going to get a certain amount of tension. It's an exact science. Well, not necessarily exact, but as close to exact as you can get.
Yeah.
Torque is it could be all over the board. I mean, depending on what kind of lubrication you use, what kind of condition your bolt or your nut is in, all that enters into torque. With the other stuff
Yep.
we're talking about here, you go directly to the tension. So yeah, that's the kind of thing we'll talk about in this presentation.
All right. Well, I'm good. It's great to catch up with you, and we will see you. But give me a call if you want to do something.
Okay, is that something you might be interested in, though? That bolt tensioning, or is that?
It doesn't have a whole lot. It doesn't have a whole lot to do with Tango, but if you got your paper, I'll put it up on our website.
Okay. All right. Good deal. All right. Good talking to you, Forrest.
Good talking to you, Al. Bye.
All right. Hey, bye-bye.